Good evening, everyone. My name is Manyatnam Prakash, and welcome to week 10 on online discussion on wastewater treatment and recycling. The course instructor for this subject is Professor Manoj Kumar Tiwari, and this is week 10. So every Tuesday we meet on this timing, that is 7 p.m. to 9 p.m., and the link for which has been already shared with you, and the recording of this session are being uploaded on this YouTube channel, the link for which has been also shared with you. So currently we will be dealing with these four topics. So first is optional and options and conventional approach. So till now we were seeing that water will be coming to this this some we have seen the first screen chamber, then going to a grid chamber, then different unit, that is first preliminary treatment is there, then primary treatment, then secondary treatment, and then there is advanced treatment. So this is the common wastewater treatment process that are being currently used. So at the most of place, this is the method. So that is, and this method is running from very long time, so that's why it is called conventional. Like it's going on from many decades. So so currently with ongoing research and development of new technology, there are many other method of wastewater treatment also. So in this lecture we will be looking into those things. One is one such system is use of wetland system. So what we will be looking, how wetlands are used for treatment of wastewater and all these things. And then there is this thing SBR and SBBR. SBR is sequential batch reactor. Similarly, we have SBR. So here there is something called batch, means we will be treating our wastewater in batch and all these things, and it will be in sequence. So that was sequential batch reactor. We will be looking into detail what are those these things. Then we have MBR and MBBR. So again we will looking into detail what are these treatment. These are the different option apart from conventional approach, and we'll be also looking into what where are those methods are being used. Okay. So if you have any kind of doubt, you can ask in comment section. So this is the picture of conventional approach. Like you can see, first there is a preliminary treatment. We are removing larger particle, then we are removing inorganic suspended particle, that is known as primary primary treatment. So these all are this conventional approach. First, it will be going to this preliminary treatment, then primary treatment, then secondary treatment, where we will be treating. We have seen actually 2-3 lectures were devoted to the secondary treatment, and where we have seen different condition under which organic matter which is present in our wastewater, which is present in highest quantity. So how those organic matter are degraded and finally converted into some useful material and all these things. Then finally we came into this advanced treatment. Suppose we want to reuse the water for maybe drinking purpose or for agricultural purpose, then we have to look into some limits that is being set up by Indian standard codes or CPCB. So we have also seen different approach, how to remove nitrogen, how to remove phosphorus, then how to remove some metals, then how to remove some dissolve solid ions. Yeah, real solid that is present in the system. So this is the conventional approach. If you visit any plant in India, so as for now, as I'm from IIT Kanpur, so here there we have the huge this there is area named as Jajmao. So we have plenty of wastewater treatment there, and you we have seen that this is the normal approach that are being followed for treatment of wastewater. But as we have seen that I have also discussed like this Kanpur is like industrial area. So wastewater which is there are there to treat industrial waste, also chromium contaminated wastewater. So we, apart from this conventional approach, there is some other thing also. USVR we have seen up, so we have discussed and all these things. So along with some conventional approach, some new technology which has been developed are also being used for treatment of wastewater. So in this lecture we will mainly focus on, because we have already finished all these four topics, so we have come to now different other approaches for treatment of wastewater. So there are different so before going in to discuss the question and answer, I will be just discussing different optional method which is used for treatment. So different alternative treatment options are: first is constructed wetlands. Okay, so if we look into its purpose, it utilize natural process in engineered system to treat water. So there is something called engineered system and natural system. So engineered system, that is being man made. Okay, now so we build some kind of setup, and in that setup we allow some natural process to occur, maybe some plantation and maybe some generally plantation are allowed to occur. And what happened that we pass our wastewater, not to, see, before going to into wetland. So this is like huge topic, which kind of wastewater has to be passed in this constructed wetland. So here I am assuming that if some is like, I will be talking in generalized way, so that's why I'm saying that wastewater will be passed through this wetland. So what will happen that with time, as the water will as the water will move through these wetlands, so there will be some degradation due to presence of microbes and all these things. So here you can see the what is the method: vegetation, soil and microbial activity work together to remove pollutants. So whatever the pollutants are there will be removed by these wetlands. So a example, so there is one professor here working on this in IIT Kanpur, working on wetlands. So what they are mainly focused on to removal of chromium from industrial waste. So they have designed some kind of material, not designed shape. They have, yeah, they have designed. I don't remember whether they have designed or did something. So those material are placed on these wetlands, and some kind of different plants are allowed to grow on that wetlands, and that water is allowed to pass through. So some with the help of some microbial activity and the ability to these plants to absorb some pollutants, those the water is being treated. So this is a combined activity. So If you want to look into details, just go search on Google Scholar the method to remove pollutant using wetlands. So you will look into the mechanism. But overall, this is like all these work together to remove some kind of pollutants. Okay, outcomes are effective for nutrient removal and providing habitat. So maybe nitrogen, phosphorus, and some pollutants are also there. So these are being easily removed. Okay, so this was constructed wetland. Second option is sequential batch reactor, that is known as SBR. So purpose is to treat wastewater in batch mode, allowing for flexibility. So what will happen that we will be discussing more about the sequential batch reactor. So just wait for some few more slide where I will be showing a real picture of SVR. So remember, batch means there will be some batch. They are set up where first what will happen that water will be allowed to wastewater will be allowed to allow will be residing in this unit for some time, and then after that, after its treatment means after one batch, the water will be passing into second batch. Okay, so it's like mm, uh, huh. So it's like the water will be going to different process, so that's why it is known as sequencing batch reactor. So we are passing, we are just treating at one time, we are allowing the wastewater to for wastewater for treatment for a particular thing. So we will be looking into more detail. Method involves filling, reacting, settling, and descending within the same tank. Then outcome is if effective for reducing inflow rates and effective for nutrient removal and all this thing. Okay, so this was SBR. Then we have membrane bioreactor. So these are little bit costly treatment methods. So generally, in our economically marginalized population, generally these processes are rarely used. But at some place, these membrane bioreactors are used. So from name itself suggests that it is a membrane bioreactors. So combined biological treatment with membrane filtration. We already seen that how membrane works. So we allow our water to pass through membrane, and the membrane has some kind of pores, and that will capture the pollutant. So now along with this membrane, we are allowing some biological treatment also. The method utilize membrane to separate treated water from mixed liquor and all these things. Outcome high quality effluent with minimum footprint and better solid separation. So here we have seen that membrane had highest efficiency in removal of solid suspension. But again, generally you will not see in your local wastewater treatment unit, because these are little bit costly and all these things. But with time, India is also adopting this method. There are many research ongoing on different institute on this membrane and all these things. Then we have moving weight biofilms reactor, MBBR. So purpose use biofilm into the moving media for treatment. So same similar to these things, but here we are we will be having one kind of a bed, and that will be moving, and that will contain some kind of biological bacteria, and means some biological activity will be going on that bed, and the water will be passing through those things, and with time the our wastewater will be treated. Okay, the wastewater flow over plastic media, allowing biofilm growth and pollutant removal. Okay, so remember the concept if you recall trickling filter. So what happened that there is some particles is there, uh, particle is there, that some inert particle is there, and that contains some kind of bacteria. So what will happen that as wastewater will be coming, so it will be providing food for those bacteria, and with time what will happen that the whatever organic matter is present here will be getting degraded. So similar things are happening here also. So there will be one moving plastic media or inert media, not mix here in the perfect word will be inert media. Okay, now that is not reacting with any kind, and that will contain some kind of bacteria and all this thing. So what will happen that once the wastewater containing organic matter is passing through this media, so it will degrade organic matter, and in this manner our wastewater will be treated, effective for both carbon and nutrient removal with lower energy consumption. Again, so this conventional, so overall, if you want to compare what is this conventional method and this optional method. So conventional wastewater treatment typically involves a multi-stage approach, starting with preliminary treatment and primary treatment, followed by secondary treatment and tertiary treatment. So we have seen, first we will be removing larger particle, then inorganic suspended particle, then we will be removing some secondary that is organic particle, and finally there will be some advanced treatment. Alternative system like constructed wetland and various bioreactor provide effective and sustainable option for treating wastewater, especially in decentralized application or area with a specific treatment need. The choice of system depend upon factors such as effluent quality requirement, cost available, space, and environmental consideration. So this is the most considered right now. This is the most important factor to select the treatment plant. So we know that this we will be we are producing huge amount of wastewater. So if we consider the real world application, so in India you can see, like, right now generally most of the treatment plant, if you visit, and there will be some quantity, like how much of water it can hold, how much water it can. So it will be defined in mld. So maybe starting for 20 mld, it can goes to 100 mld. So 20 mld, 20 million liter per day water. So generally a wastewater treatment, it is the least 20 mld, generally considered as least. Okay, now this much wastewater is coming to a wastewater treatment plant. So remember this membrane and all these things. So if this huge amount of water is coming, so a huge maintenance is required. So this process is really costly. Okay. So anyone uh, if anyone have any kind of doubt, you can ask. Okay, na. So either you can write in chat box, or you can just unmute yourself and you can ask the question. Chat box is always open. Okay, so this was all about different so right now what will I will be that was overview. So I will be just discussing some of the wet fields that are generally used. So this thing we have already said, that constructed wetlands are engineered system designed to treat wastewater. Engineered system is that are man-made, designed to treat wastewater by utilizing the natural process that occurs in wet. These system integrate biological, chemical, and physical process to remove contaminants from wastewater, making them effective and sustainable option for treating wastewater. So first is surface flow. Name itself suggests that it will be surface flow wetland. The wastewater flow over the shallow surface of the soil and vegetation. Okay. So remember, this will our way our so our wetland will be looking like this only. Okay, now. So surface means it is just passing through on the surface. Means you can see the over the shallow surface of the soil and vegetation. Shallow surface means there just on uh, shallow surface means it is just passing over this over the surface of this soil, that is the surface of soil and vegetation. So water will be allowed to pass through this wastewater will be allowed to pass through this shallow surface. The mechanism is similar. Say mechanism is almost similar for all the kind of wetlands. So depending upon the area, cost, and all these things, different kind of wetland are constructed. Okay. Advantage is effective for removing suspended solid nutrients, pathogens, and can provide habitat for wildlife also. So this is the most simple wetland that are being constructed at many places. Second is subsurface. So I will just show you one picture. Like I am not. included any picture. So how these how these wetlands. So you can see like it's general. It's not that good picture. Just 1 minute. I don't remember if my lecture contain this thing, but this. Huh. See, this is like so this I was discussing. So you can see here. So I hope you all are able to see my uh, uh, see my this PDF. Okay. So here. Here you can see that this is vegetation. So remember, first this is all our engineer system. These are being man-made, and on there is certain portion where this vegetation is allowed to grow, so that is known as wetland plants. Okay, now, so what will happen that the water will be coming from this side, and you can see that water is going through this you can see that water is going through this gravel. So here you can see different portion is there. So first this p gravels are there, then here large screen river gravels are there, and water is allowed to pass through these wetlands, and finally happen what is happening that this wastewater is interacting with the roots of these wetlands plants. Okay, now remember these wetlands plants are very specific plants. It's not like that we can grow any kind of plants here. So I don't remember the names of these plants, but if you search what is this wetland plant, so you will see a specific plants that is able to remove nutrients, that is nitrogen and phosphorus, in large quantity. Okay, now it's not like that I can grow any plant. And finally what will happen that water will be passing through this outflow, and it will be treated wastewater. So here you can see subsurface is there, then we have overflow. So this is subsurface, and here we have overflow, means water here only the lower portion of the wetland, lower portion, that is this a smaller gravel which is this larger gravel which is presented there, water is passing only through this portion. That's why it is known as subsurface. It is occurring within the surface of, that's why it is not subsurface. Then we have surface plus overland, means it is passing through above this area. You can see the surface is here, but water is passing through that area, and it is utilizing both, that is roots and the some portion of the plants. And here you can see that we are growing two different kind of plants. So let me see if name of the plants is written or not. Name of the plants is not written, but you can search anywhere that what are those kind of plant, various natural process, wetland vegetation, constructed. So I hope you might have idea of how these things is these things are working. If you have any kind of doubt, you can just ask. We have already looked into subsurface flow. Then there is vertical flow, similar to here we are what we are seeing, that water is passing horizontally, water is passing from here to here. So there is some kind of arrangement also where the water is passing vertically. Okay, now, so that is more advanced thing. So water is applied to surface and flow down through the media. Okay, so some media will be there, and water will be flowing vertically. Okay, the vertical flow promotes the aerobic condition in the upper layer and the anaerobic condition below, facilitating the different treatment process. Compact design, effective for nitrogen removal. Okay, these are some of the definition. Generally, people are generally if you are studying about wetlands, you should know. Okay, now what are different kind of the subsurface, surface overflow. So if we look into the benefits of this integrated wetland system, it is cost effective, lower operational and maintenance. You can see the picture because you can see, you have seen that you have to just design something, and in between that you have to plant some a specific plant. What is your like, what do we call, what is your like need, what do you want to remove from that water. So sustainability, utilize natural process and minimize energy consumption. Then biodiversity, provides habitat for various plants and animal species, enhancing local system. So it's like that in the plants where we have seen that uh, 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 we have seen that our system was like this. So here gravels was there, and in between the plants were there. So here some kind of vegetation and some kind of animal habitat can also occur. Aesthetic, you can enhance the landscape and provide. So there are some wetlands which is very aesthetic in look, so it will give you very good scenery. So but there is some so there it has some disadvantage also, means like it is considered as not so much efficient. Okay now, so some, I have not mentioned, but you can always go and search what is the disadvantage of this wasteland. Okay, so one thing is that it required regular maintenance, because you can see that these plants can be attacked. Okay, then we have plant selection. Native and robust wetland plants should be chosen for optimal growth and pollutant uptake. So it's like that we cannot grow any kind of plant. So we have to be a specific. So that plant selection. Then hydrology, proper water flow and retention time are essential for effective treatment. So here you can see that generally the residence time is, means residence time for how much the water will be residing in this wasteland is around 5 to 10 days. So it's like so we have to look into those things. Okay, then second thing is hmm, so again I was discussing about the sequential batch reactor. So sequential batch or sequential batch biofilms reactor. Okay na, so our advanced wastewater treatment technology that offered flexibility and efficiency. So this are advanced wastewater technology that offer flexibility and efficiency in treating various types of wastewater. Both system operates in batch mode, allowing. So before going to discussion, so this is like this is the real picture of a batch thing. Okay now, so what will happen that water is the wastewater is going through different sequence. Okay now, so first there will be suspended growth sequence batch approach. Then there will be some aeration, so to provide some air. Then will be high quality effluent will be passed. Okay, then moving system of bears declare required complex operation. No, sorry, so sorry, this was all characteristic. So but here you can see first water will be filled, then some aeration will be allowed, and that will allow for some kind of reaction and all this thing. With time what will happen that next batch will be allowed for settlement, and the next batch will be to draw the effluent. Okay, and the solid will be remaining in the batch only, this batch reactor only. And again we will be have very low quantity of water, then this sludge can be removed. Again what will happen that next this system is ready for our next treatment. So next batch can be next batch of water can be added, and we will be having another set of another set of treatment. So SBR type of activated sludge system that treats wastewater in a single tank using a series of operational phases. They are particularly suitable for treating domestic sewage and industrial effluent with fluctuating loads. Fluctuating loads. Okay. So typically SBR in four phase, that is filling, wastewater is introduced into the reactor, then the mixed liquor undergoes aeration promoting the biological degradation of organic matter and nutrient removal. So what will happen that as it is known as activated sludge, so what will happen that this system will contain some kind of bacteria. Okay, now so that will be already activated. So once this water will be filled, wastewater will be filled, and then some aeration will be done, and as aeration will be done, so this the wastewater, the bacteria which is present here has got food and oxygen, so it will start degrading our organic matter. Then aeration stops, the biomass settles at the bottom of the tank forming a clear supertenant. And then we have descenting, that is the treated effluent is removed from the top and the remaining sludge can either be discarded or returned to the system. So generally, so remaining sludge so sludge is most of the sludge is removed, and but they, to activate our system, some sludge are also kept into this reactor. So this is all explained in this operating cycle. So this is a real picture of real picture of SBR. Here each treat remember the different process are going in each reactor, in each cycle. Okay, in each unit, not cycle, in each units. If you have any kind of doubt, you can ask. No one is like. I hope you are understanding it. What I'm saying. Advantage is flexibility to handle various inflow rates and composition. No need to separate clarification unit, reducing a space requirement. As we know that it's all happening in one single tank, so that's why uh, there is no need of such. If effective for nutrient removal, disadvantage batch operation can lead to flocculation in if you lent quantity. So what happened that so we are like batch operation can lead to fluctuation in effluent quality. So sometimes what will happen that if proper maintenance is not kept, so for suppose we are running for first time, or maybe for initial time we are taking proper care that this much amount of activated sludge is there and this much amount of water is there, and we are using same reactor, same batch, for same instrument, same reactor for different batch. So what will happen that if some pollutant is there, that might be getting accumulated in the system, so what will happen that the efficiency will be getting decreased. So if proper maintenance is not done, so what will happen that initially, suppose initially it was able to remove the 95% of nitrogen, but with time some accumulation is there and the sludge are being not removed, so efficiency from 95% it can goes to 90% or 80%. So there will be fluctuation in effluent quantity, require careful monitoring and control of operating parameters. So every batch, if you want the quality of effluent to be good, then you have to take a proper monitoring, and you have to, whatever the parameter has been set, you have to meet those parameters, that not more than this sludge should be accumulated for the next cycle and all these things. So again we have this SBBR. So SBBR combines the principle of both batch operation and biofilm technology. They utilize biofilm attached to the support medium for treatment process, allowing for enhanced pollutant removal. So again miss, like it is also same thing, but it is using the biofilms and all this thing. Okay, now again here the process is same, but it include biofilm development on media. Okay, so wastewater is introduced, filling the reactor, aerobic condition are established, allowing the biofilm to metabolize organic matter and nutrients. Okay, So here instead of aeration, some kind of aerobic condition will be maintained. And what will happen that here you can see that no such thing was, no external thing was added. But in SBBR some kind of inert material will be added. So what will happen that it will enhance the growth of microbes. Okay. Along the reactor transits to a settling, again the same process, settling and descending. Okay, now advantage is that enhance removal of organic matters and nutrients due to combination of suspended growth and attached growth process, improved the resilience to the shock loads and toxic compounds. Like if what will happen that shock load means, sometime what is happening that initially maybe nitrogen which was coming has a concentration of only 150, but out of sudden in second cycle the concentration has increased to maybe 300. So it is a kind of shock to the system, that initially it was coming low amount of nitrogen, now suddenly high amount of nitrogen is coming. So it is a kind of shock load. So it can handle, this biofilm reactor can handle those kind of shock also, reduce a space as compared to, again this is similar to this SBR also, that it as everything is happening in a single reactor, so it is reducing the space potential for clogging the media. Again, wherever we are using some kind of media membrane, so this the a high maintenance cost is required. Okay na. So because you have to remove those, you have to regenerate those membranes, so and you have to maintain, because these are easily clogged or easily become non-operational, so you have to take a proper maintenance. Both SBR are used in various applications such as municipal wastewater treatment, industrial wastewater treatment, decentralized treatment. Okay, so I hope these all things are clear to you.
Yes, sir. Yes, sir.
Okay, if you have any kind of doubt, you can always ask in chat box. So this thing, coming to the last two option, that is membrane bioreactor and moving biofilm. So it's similar to, so again here we are using membrane bioreactor. So name itself suggests that we have membrane that contains some kind of bioreactor. Okay. So our advanced wastewater treatment technology that offer efficient pollutant removal and improve effluent quantity. Both systems are designed to enhance the treatment process while minimizing the space requirement and operational complexity. So again, these are some, see, if you look into the conventional, those all units require very large area, and so large area, large time. But these are again with technology, advanced research, they people have developed some kind of membrane and all this thing that is reducing a space. The the treatment process is very fast, but on other hand it is also increasing the cost and all these things. So both have their limitation and advantage. Okay na. It might be working very well, but now remember, suppose if you suppose there is some town, means not so for India, considering in India only, there are few places only where these advanced treatment are followed, just because of economic purpose. We are not able to uh, we are not able to, what do we say, the- we have technology but we are not able to invest on these things. Maybe it can, there are several problem, I hope you are understanding it. So MBR combines, that is MBR combines with biological treatment process with membrane filtration, providing a robust solution for wastewater. This system uses membranes to separate the treated water from mixed liquor, allowing for high quality effluent with low solid contents. Okay, now. So what will happen? See, this mixed liquor is like this mixture of organic matter and this our water and all this thing. Okay, allowing for high quality effluent with low solid content. So what will happen that Remember these membranes are they have a specific pore size that this will be able to remove this kind all the solids which are above the size of this. And along with that there is some kind of biological process also. So the membrane is like removing all the suspended solid or solid low solid. So what will happen that all the solids are being removed, so the water which will be coming will have very low solid contents, okay now. And apart from that there is some kind of biological treatment also, okay. So but here you can see biological treatment: water flow into the bioreactor where microorganism degrades the organic matter and nutrients. The overall process is same, that if by some kind of bacteria is there, if that will be coming in the contact with this wastewater containing organic matter, it will degrade. Now the question is how you want their interaction. So here they are using membrane. So it is doing two things: it is removing solids also, and it is removing it is removing organic matter also. If you recall this thing here, there is no control over solid content. Whatever solid is there, we are just moving at this point. We are allowing the gravity to, if some solids is there. But we have seen in primary treatment, but there are some solid which which cannot settle on its own. We have to add some chemicals and all these things. So these things are being not controlled. But another process is that if you don't want to add chemicals, just use a membrane and allow the water to pass through those membranes. So what will happen that this membrane will collect those solids, okay. Membrane, the fixed mixed liquor is passed through the membrane that retain biomass and solids, allowing the only treated water to. So once what will happen that once these organic matter are being degraded, so it will be retained on these membranes, and finally we will be having a treated water with very low solid contents. And organic matter has been already degraded. Means when we are seeing organic matter, means we are seeing that high nitrogen and high phosphorus. So we will be having water with low nitrogen, low phosphorus, low solid, okay. Then back washing is also required. So now we know that all always we are passing the water through these things. So what will happen that biomass will be getting accumulated on this, on the surface. So we do something called back washing to clean our membrane. So what will happen that uh, whatever the solid biomass has been attached on the surface will be removed. The membranes require periodic backwashing to remove accumulated solids and maintain permeability. So I hope you have understood this thing. Advantage, I already said, is the high quality effluent suitable for reuse purpose, a smaller footprint compared to traditional treatment system due to integrated design, effective removal of suspended solid, pathogens and nutrients. Then we have disadvantage: high operational and maintenance cost, which we have already discussed. Potential for membrane foiling, which require careful. So there is like all these things. If you combine both point, it is very costly, because for maintenance also a person should be there. Not a single person, a group of persons should be there who can regenerate the, can do back washing and clean our membrane and all these things. Then we have moving bed, another kind of biofilms is there. Another kind of biofilms is there. Uh, hmm. Membrane utilize biofilm technology on plastic media. Plastic media, not here, should be inert media to treat wastewater. The system consists of a tank filled with suspended media that provides surface area for microorganisms to grow effectively, treating the wastewater. So first there will be some. So they consider this is as a unit, a kind of bed, and it will contain some kind of inert media. And here we will be have some organic matter will be there, okay na. Sorry, not plastic material will be there, and on plastic material, this inert material, some bacteria will be there and it will be growing. So the wastewater flow through a tank filled with the moving plastic, where the biofilms on the media surface. So we have already biofilms, and what is the purpose of these biofilms? So that will degrade our organic matter. Then also on the system air will be provided. And remember, it is all moving, okay na. So the moving is done in such a purpose that there is a natural aeration, so there is no external aeration is not provided. So the movement is in a such a way that there will be some splashing of wastewater, and what will happen that we will have proper aeration. The system typically includes aeration to provide oxygen for microbial metabolism and maintain the movement of the media. Okay, and finally we have separation. After treatment, the effluent passes through the clarifier where the biomass settle out and treated wastewater is collected. Okay, so enhanced treatment. I hope you have this biofilm, some kind of reactor, some kind of media will be there, water will be passing, there will be some kind of degradation, and we will have high quality of effluent. Okay, enhanced treatment efficiency due to combine of biofilm and suspended growth process, reduced footprint compared to traditional methods. Again, same, this membrane and MBBR are doing same thing, that it is decreasing the space. Ability to handle shock loads. Again, I have discussed about the shock loads and all these things. Then we have disadvantage, potential for media clogging, same this thing, and again costly. Okay na. And if we look at the application of the MBR and MBBR, this suitable for a small to medium size facility where high quality effluent is required for the use or discharge. Remember, these kind of investment are done if we are treating our wastewater for the use purpose. There is one country, this Israel, there where they are using around 80% of their wastewater. They are using it, so they are investing too much on their this thing, treatment process. So they are using this kind of technology. So in India, we are still very, and they are managing their water. So you can just there is documentary also how they are managing their water and all this. So whenever it's come to the maintenance of water and wastewater, that the name of that country comes first. Okay na. So you can always go and look how they are treating their wastewater, how they are managing their water, groundwater, normal water, wastewater, and all these things. And the one thing is that they are getting this funding and all this thing in huge amount. So they just invest on these advanced technology suitable for a small to medium facility, industrial wastewater and decentralized system. Okay, so these all were like kind of some details regarding different kind of operational treatment method apart from conventional method. So generally the question related to generally there are very few questions that you will be looking into wetland and all these thing, but I have also miss I was able to get some question. So miss, I think I have just given the solution also, but just for your own mhm, own curiosity, if you want to solve it, just try to solve it. A constructor, okay, just I will just discuss it. If you want to solve it, mm, if anyone want to solve it, just they can solve on their own paper and pencil, paper and pen. So the question is generally question related to these are very simple question. Okay na. A constructed wasteland is to design treat this much meter cube of water per day. This much meter cube, 200 meter cube per day of wastewater. The wetland designed with a hydraulic loading rate of 0.3 meter per day. Okay. If the wetland has a length to width ratio of 3:1, calculate the surface area of the wetland. the dimension, length, and the width of the wetland. So remember, first generalize the, like, you should have a picture, means you should have an idea how wetland look. If you are able to, like, if you know this uh, picture, see, this is the length, this is the height. You can see the length in the direction of flow, okay, and this is the height. Remember, this is means these all of are part of wetlands, okay na. And these kind of some, these are some kind of other, means I have not discussed why there is some kind of um, this kind of arrangement is there, but they have their own purpose, okay na. So miss, I will request you, there are some book which discuss about these wetlands in more detailed way, how these wetlands are constructed. But for now, just remember, this will be length and this will be your height, okay na. Remember, the hair to hair height is from hair to hair only, okay na. The plant of height is like independent. If we see, miss, hmm, and this is the real picture of our wetland. Where did this is the real, miss, you can see actual of constructed in operational. You can see it's not clear, but there will be some area will be marked and it will be saying that this is wetland and all this thing, okay. The question is very simple. So the subsurface area will be flow by hydraulic rate, means how much uh, hydraulic loading rate, means like how much water is flowing with on is from one end to another end, okay na. So this was very simple. The surface area will be given by flow by hydraulic loading rate. The flow is already given to you, the hydraulic rate is already given to you. So the area will be this much meter cube, let L, and already given the question is 3:1. So if the L is L, then W will be 3W. Then surface area will be L into W, and we have already, then W square will be this, then L will be, so if length of the wetland is 14 meter, then the height will be around uh, length, width, sorry, they are not discussing about length is to width, and they are not discussing about height, okay na. Oh, sorry, just 1 minute. This was very this was very simple question. So remember, that picture was miss from, we were seeing from side, but it obviously it will have some length, and it will have some width. So they are just talking about this length and width. In that picture we have, in that picture we were not seeing this width, okay na. So how, in how much area this that wetland has to be constructed, okay na. So this will be length, this will be width. So this picture will be from top, okay now that picture we will be seeing from side wise. Again, we have another question related to SBR. So SBR operates in a cycle of 6 hours. So remember, there were 4 cycle of, every cycle is of 6 hours. It treats this much meter cube of wastewater per cycle with a effluent COD of itna and achieve 85% COD removal. Calculate the number of cycle per day, the total daily wastewater flow, okay, and the effluent COD concentration in milligram per liter. So this is also very simple question. The number of cycle per day, each cycle is 6 hours, so number of cycle per day will be 4 cycle per day, okay. Obviously in 24 hours there will be 4 cycle, okay. The system treats 50 meter 500 meter cube per cycle, so total will be 500 into 4, that is 200 meter cube per day. So this is total amount of wastewater that is being treated. Then we have effluent COD. Effluent COD will be effluent COD minus equal to influence COD into 1 minus removable efficiency. So whatever being incoming, 85% is getting removed. So this much minus this into 85%. So that is 50. So the effluent, the COD which will be coming will have COD of 52.5. So with the help of this, now we know the efficiency, and so from here we can have an idea that where should I throw this wastewater, treated wastewater, or either can I reuse this wastewater. So we know that as per CPC, Pollution Control Board, they have given some CPCB, Center for Pollution Control Board. Okay, na. So they have given some limitation that if COD is between this and this, then you can throw your treated wastewater in on land. If if the value is this much into this, you can use for irrigation purpose in agricultural field. If the value is between this to this, then you can throw in C and all these things. So it's all depend upon the efficiency. So this is how in real world people generally look into these removal efficiency. Okay. Again, one question, simple question is there related to MBR, that is treating this much of wastewater with effluent suspended solid of this much concentration. The efficiency, MBR has a filtration efficiency of 98%. Calculate the total suspended solid. Again, total suspended solid will be flow into influent total suspended solid. Okay, so 5 meter cube per day was coming, and effluent has a solid concentration of 300 milligram per liter. So the total load will be 15. So this we know that we will be converting liter into meter cube. That 1 liter is equal to 10 to the power minus 3 meter cube. Then we have we have also converted it to liter, kg into milligram. So what will happen? So you can see that finally we will be having 1500 kg per day. Okay. Hmm. Then amount of suspended removal, again this is same TSS load into filtration efficiency. 1500 kg per day was coming, efficiency was 98%, means how much TSS was removed. TSS was removed 140 1470, means this much amount of per day was coming, out of which this much removed by this MBR. You can see the efficiency is 98%, very high removal efficiency. And initially the water which was coming going into the system has a suspended solid. Total suspended solid has a concentration of 300 milligram per liter, and finally, yeah, the water which is coming has only TSS of 6 milligram per liter, which is a means you can just imagine how much suspended solid it has removed just because of presence of membrane. Okay. So last question is related to this MBR system. And MBR system is designed to treat this much of water. The influent ammonia has a concentration of 30 milligram per liter. The system remove 85%. Similar question to what I have discussed previously. So in I mean, in each question you can see that here this was simple question, but here we were mainly focus on chemical oxygen demand, that is COD removal, SBR, because we know that apart from this it can remove COD. In this question we were looking into suspended solid, removal of suspended solid, because we know that membrane is generally used to remove suspended solid and all this thing. In this question we are looking into ammonia. Generally ammonia will be, see, organic, there is no proper way to define our organic matter, that this much kg of organic matter. The best way to define is how much nitrogen and how much phosphorus is there, and that nitrogen can be in any form. So they are just saying that this much nitrogen is there in the form of ammonia in that wastewater. So it's just a way of saying that this much ammonia is present here. And from here what we can see that so generally see how the thing is thing is uh, how anything is designed. So it is always designed in reverse engineer way. So now suppose in an area suppose there is treatment plant, there is a plan to construct this MBR system. So the first question will be that the treated wastewater which is going to being released, what is the purpose? What are they going to use? For what which the treated will the treated purpose the treated wastewater will be used for irrigational purpose or for drinking purpose. Depending upon that, this system will be designed. So here means this 85% is not like randomly chosen. So what happened that suppose it is suggested that the treated water will be used for irrigational purpose, and then as per CPCB, we know that for irrigational purpose, say x amount of ammonia should be present in the x amount of nitrogen should be present in our wastewater. Okay, na? X amount of wastewater should be present in wastewater. So what will happen that so our x amount and we already know that with population, number of wastewater, number of volume of wastewater, we have already done some kind of uh, test, and we are already aware that in this area, in this whole area, say say three say um by milligram by amount of nitrogen is present, and our purpose is to use our treated water for irrigational purpose. So our efficiency of this system should be such that it should be able to it should be able to treat by amount of nitrogen to x amount of nitrogen, and in that way we will be defining our efficiency. Okay, I hope you are able to understand what I am saying. So here you can see that they are saying that this is just a question, but this is in reality this is how system works. First we do this testing, then what will be the purpose of our treated wastewater, and depending upon that we will be designing our system. Okay, now the effluent ammonia. So here you can see that the loading the ammonia loading into system, this was pre-known to us by doing some conducting some survey and some sampling and all these things. So this much kg per day of ammonia is coming into the system. Ammonia removed means how much remove I have to remove my ammonia from by minus x. This much I have to remove. So here they are saying that 85 depending upon that we will be having our efficiency. So here ammonia removed is 150 of 85%. So this much of ammonia has been removed. And remember the effluent which is you can see finally depending upon the efficiency, the final concentration is of ammonia, and if it matches our CPCB rule, then we can discharge this water for irrigational purpose. So this all was about some kind of numerical, some theory. This was all about wetland, SBR, SBBR, MBR, and MBBR. So, and from next onwards, we have some question related to these topics, which I will be again discussing one by one. But I want you all to participate in that question and answering, because I have given if you have gone through the lectures, uh, it was detailed lecture on NPTEL portion. Again, I have given around how much one and more than 1 hour to discuss those things. So I think it will be very easy to answer all those questions. Okay. So till now, if you have any kind of question, you can ask in chat box, or I will be moving forward. Okay. So Any question, anyone? Okay, so coming to the question, just try to write it. Just be active in chat box. Try to answer this question. So you have to identify which one is correct and which one is incorrect. So the choice of wastewater treatment depend upon several factors such as desired degree of treatment, cost, and available funds and sustainability of technology. Statement 2 is in general, natural process wastewater treatment units always provide most efficient contaminant removal. So there is statement 1, statement 2. So this is very simple question. Which one is correct? Which one is incorrect? Out of these, we have to select option A, B, C, D. Option A, we have got one answer A. That is statement 1 is correct and statement 2 is incorrect. Other anyone? I request everyone please participate. A. What sound? Please turn off your mic. Oh. If you have any question, you can just unmute. Sorry if you. Okay. So this was very normal question. So we know that the first option is correct because yes, we how much degree of treatment we want. It's all depend how much funds is available. So first statement is correct. Wastewater treatment are selected upon multiple consideration. These include type of contaminant to be removed, the level of treatment required to meet the regulation or environmental funds. Okay, just remember, it's all are connected to each other. We are if we are using our treated wastewater for drinking purpose, then it should meet the IS code, a standard code of drinking water parameter, that is IS 10500. If it is for educational purpose, then the rule set by environmental standards by CPCB, it should meet those criteria and so on. Okay, the cost of installing and operating the system available for financial resource, and the this is all, I think. So this statement is correct. This statement is incorrect because we have seen that engineered, most of the treatment units are engineered means man-made, while natural process like constructed wetland, stabilization pond, and biofilter are efficient for certain type of contaminants, but they not be provide the highest level of treatment compared to the more advanced and mechanical treatment. These natural system can be limited in terms of land area requirement, treated speed, and their ability to remove certain pollutants. Thus, this is, statement is incorrect. So generally, man-made and this thing, they can remove this. For example, membranes. If we try to remove our solids via natural process, it will take lot of time, and we might not be getting the efficient result. But if we use membrane, then that can remove our wastewater, that can our treat wastewater by removing organic matters and solids in a very efficient way, and efficiency will be more than 90%. Okay, so uh, it's always that people are depending upon this engineer system. Coming to the second thing, which of the following is a major treatment mechanism in the constructed wetland? So directly I have not used the term, but I have said that plants are used to remove and all these things. So just go through one by one option where this advanced oxidation occur, where this phytoremediation occur, where this disinfection occurs, and based on this try to answer this question. Which of the following is a major treatment mechanism in the constructed wetland? Anyone in the group? So this refer to the chemical process that products. If you remember the last class, we have discussed about this hydroxyl OH dash OH. Okay, so this is known as hydroxyl radicals. To break down the it is not natural process typically of constructed, but rather advanced engineered chemical treatment. So here it's kind of disinfection process only. Like advanced this we produce this kind of radicals and introduce in our water, and it will kill, it will just remove any kind of contaminants or biological things is there. So this thing is not happening in our constructed wetlands. Phytoremediation refers to the use of plants and degrade or stabilize the contaminant in environment, particularly in water and soil. In wetland, the plants absorb contaminant through roots and microorganisms associated with plant roots to help. So we know that in our wasteland we have this plant in the middle of, we have generally we have plants, so that plants remove the our contaminant with the help of process known as phytoremediation. Again this disinfection is another thing, use of chlorine and UV and all these things. This is not happening in our wasteland. This is another treatment unit that is happening in conventional where we use chlorine or UV or some kind. Okay now, they do not primarily rely on disinfection mechanism like chlorine or UV treatment. Their pathogen removal is more passive, involving process like sedimentation and exposure to natural lights. Okay, so the correct answer is B. Try to match the following. Okay, na. Again, just this is like again question related to constructed wetland only. Okay, na. How suspended solids will be there, how suspended solids are removable, how organic matters are removed, how nutrients are removed. So this is not just related to constructed wetland. So this is a generalized, okay na, generalized process. Just try to answer in that way. How suspended solid will be removed. In normal process, how suspended solids are removed, how organic matters are removed, how nutrients are removed. We have answer B. First is B C A. Yes. BCA will be the correct answer. Because see, for removal of suspended solid, so remember our system was like this. There was gravels and all this thing. Okay, now and water was passing through from one direction to another direction. This kind of arrangement was there. This kind of arrangement is there. Okay, now so here you can see as the water will be passing, all the organic matter which will be there will be degraded by organic matter will be degraded by microbial activity. Nutrients will be taken care by this plant, because we know that plant can take nitrogen and phosphorus, and there will be filtration due to presence of these gravels and all these things. Okay na, on in that way suspended solid will be removed. Okay na, so the correct answer is B. So in construction, suspended solids are primarily moved through the principal as wastewater flow through the wetland. Suspended solids settle out due to gravity, and the plants physically trap these particles. Okay, organic matter soluble organic matter such as biodegradable compound is broken down by the microbial degradation. Microorganism in the wetland degrade organic matter under the aerobic and anaerobic condition, converting them into simpler substances. Then we have plant uptake. Yes, yes, Sambhaji, you can unmute your. You were not audible, Miss. Your voice is not coming. So your voice is not coming. We are not able to hear you. You can write in chat box. We were not able to. Okay, I will be moving forward. Objective of providing linear liner in constructed wetland is. Okay, so this thing I have not discussed, but if you have gone through your lectures on NPTEL portal, you must have seen what is this liner. So the answer for this is okay. In constructed wetland, the liner typically made of material like clay, geomarbles, geomembranes, or other impermeable substances is primarily installed to ensure that wastewater and the contaminants do not slip into the groundwater. This helps them maintain the integrity of the wetland system and prevent the contamination of surrounding groundwater resource. So I will just show you the again. I will go to this picture. So here you can see this liner is there. You can see everyone. I think everyone is seeing my this PDF. So so there is some kind of a membrane is there. So what we know that our wastewater might contain some kind of pollutant. So and now imagine what we are doing that. Just 1 minute. Hmm. If somehow if we are not providing any kind of material to and if I am allowing my water to percolate in the system, so what will happen that whatever the groundwater is there, it might contaminate that water we don't want. So we provide a kind of liner, so that is like that is saving our any that is not allowing the water to percolate in to the groundwater. Okay na. So this is liner. Then again this is. So I hope you just while looking at the picture you can just imagine why we are doing this. We are just doing, we are just making sure that no water percolates in our groundwater, and through soil it does not contaminate our groundwater, and our groundwater is safe and secure. Okay. So generally, wetlands are misused. Miss like I have, as far I have read, miss this is being used to uh, treat means many study has been done to treat industrial wastewater contaminated with some kind of pollutant. So this wetland is nowadays miss, it is used in high amount. Okay, na. So what will happen that this plant will take those contaminants. Suppose chromium is there or any kind of contaminant is there. So iron is there. So what will happen that not, I'm not sure about chromium, but I have heard about iron, that these iron can be uptaken by these plants, and we will have, and we don't want our iron to go to in the groundwater. So that's why we provide a kind of a liner. Okay. So these liners are made of some kind of clay, geomembranes, or other impermeable substance. Okay. So the correct answer is C, to prevent wastewater or pollutant leaching to groundwater. If we look into the other option, then this is incorrect, because the line these are liner doesn't have to, does not control the biomass growth and okay na. So again we have this we identify the type of wetlands. Okay na. Remember, water is flowing here. You can see inlet is there, water is going here. Then free, then we have four option: free water surface. I have shown you picture also. All these are horizontal. Okay na. And then we have vertical flow constructed wetlands. Here we are allowing water from here. We are allowing water from here, and the inlet is here. And there is a slope of 1%. Gravel is there. This is liner. Then we have air pipe. Water is there. So can anyone tell which kind of wetland is there? This. See, horizontal subsurface flow constructed wetland. Okay, let's see. Uh, it is D. Not, you can see, miss, subsurface. I have shown you. Subsurface look like this. Water is coming from here, going from here. Water is coming from here. Inlet is there, and water is going here. And I have also discussed vertical flow. I don't know why did you say C. See, I have said about vertical flow. Vertical flow wetland, which water is applied to on the surface and percolates down to the media. Means water is being, so here you can see water is being applied on the surface and it is percolating in the media. So I am not showing the picture of, so here you can see the water is coming from the top and it is percolating and it is going somewhere. So it's not like horizontal flow, water is flowing in downward direction. So answer will be D. I don't know, this was simple question. Can you see this? See, you have to, you can see different picture. Obviously this question was, you have to see how, where is water coming, how is water flowing, and how is water going. Here in all this picture you can see that water is coming from this direction and it is going in this direction. It's not like that water is coming from any up top. But in this picture you can see that water is coming, inlet is here, water is coming from top, means it is like going downwards. So the flow is vertical, and finally the water will be collected in this pipe and it will be going to the outlet. How water, see, if we are looking into the movement of water, always look how the inlet, the water which is coming in your wetland, how that is moving. Here you can see that, water first, whatever the water is coming, It is coming on the here, and then it is going downwards in that way, and finally after there will be some this kind the pipe which is there will have some kind of what do we call, some kind of subsurface is this. Surface is there, then there is subsurface. Here you can see this was our surface. This just 1 minute. If I ever go pen pencil. So, so remember, this is our surface. This is the surface of our this is surface of our wetland. But you can see the water is not going above the surface. It is always below this surface. So that's why subsurface. It is not it's not going above the surface. That's why it is known as subsurface. But here you can see that water is above the surface. That is why it is known as overland flow, or miss water is present on the both sides. That is below the surface and over the surface. There is surface. If it is downward, it is subsurface. If it is upward, it is over surface. Okay, so this is here the water is coming from here to here. Then it is then there will be some kind of perfocation, and you can see there is 1% slope. So water will flow from here to here. We are always looking into how the wastewater is coming. So the answer will be D. This figure shows where the water enters from the top, percolates through the gravel media, and is collected by the drainage pipe at the bottom. This presence in the air also suggests the aeration system common in the vertical wetland. In vertical flow constructed wetland, wastewater is introduced to the surface and allowed to flow down to the surface. So, the D will be correct answer. Okay, I hope this. Uh, I hope this is clear to you. The major difference between activated sludge process and SBR. ASP is activated sludge process, and then we have SBR. Remember the mechanism of activated sludge process, where we have this kind of tank, then we have another kind of tank, and there was some kind of recirculation, and finally it was connected, and finally we have treated wastewater. Okay, na. So here we have some kind of. So if you miss it is miss, like it is asking something, you should recall what is activated sludge and all this thing. The option are activated sludge process work under anaerobic condition, while work under aerobic condition, while this works under anaerobic condition. ASP incorporates settling of biomass in secondary clarifier, while SBR does not include. The ASP works as continuous flow reactor, while SBR works as a batch process. SP is less surface area intensive than SBR. So you see, if you go into deep, every option is like, if every option is a kind of a difference only, but they are asking that major difference apart from first option. Yes, correct answer is C. So see the activated sludge process in this water is treated in a continuous flow reactor. The process include aeration, where microorganism breakdowns matter, followed by secondary clarifier where biomass. So here there will be breakdown, then here will be secondary clarifier, here there will be sludge and all this thing. You remember ASP na? This is the conventional. So this is like a secondary clarifier. Okay na? Followed by is settled. Okay, but in SBR the system operates in batch. We have seen that after first process, second process will happen, then third process, then fourth process, and at one time only this much amount of water will be treated. We have seen one numerical problem related to this also. The the system operates in batch rather than continuous. Wastewater treatment occurs in cycling, filling, aeration, settling, and descending within the same tank. Each cycle is completed before the next batch begins. uh, Regarding other three option, ASP work under aerobic condition. Both system works under this aerobic condition. Oxygen, you see there also some oxygen is required. Here aeration is also done. In both tanks there is some kind of aeration. Okay na. So both work under aerobic condition. So that was not a difference. Settling biomass secondary by SBR does this is incorrect. While SP uses separate secondary clarifier, SBR incorporates settling within the same tank during the specific. We have seen this thing. Okay, now in activated sludge process, the sludge will be the treated water will go there and sludge will be separated here. But in SBR, it is happening in the same tank. Is less this is not necessary. As SBR system are more often complex resolve treatment which can make them less area intensive in some area. So SBR is less area intensive. This ASP is more area intensive. Okay na. So this is also, it depend means it's not entirely correct. So at some places there are high chances that SBR will be of high of less area intensive. Okay na. And ASP is of means this can be true also. Okay na. But this is not a major difference. The major difference was only C. ASP works as continuous and this works as a batch. It's from name itself suggests sequential batch reactor. Again, this is related to your batch. This carbonious BOD removal in SBR is achieved during. So we know that there is two things when organic matter degrade. So first there is this carbon, first carbon will be removed, then nitrogen will be removed. Okay na. So we know that and we know that just look into this picture. Always remember this picture. There is fill, react, settle, descend, then idle condition means the system. So at which point all the carbon, all the organic matter is getting reduced. Okay na. Just based on this memory picture, try to answer this on react phase, on descent phase, on ideal phase, or on in settle phase. React phase. Okay, so react phase is the correct answer. So in sequential, the treatment consists of several phases, with react phase being the specific design for biological treatment. So here all the aeration will be given, microbes will be degrading our organic matter. So yes, the correct answer is A, that is react phase. React phase, during this phase, the reactor is filled with wastewater and the aeration is occurs along the microorganism to break down the organic matter, including the carbonious BOD. This is the primary removal of carbonious BOD takes place. So A is the correct answer. Regarding other unit, descent phase, in this phase, what happened that there is separation. Okay, now remove from reactor after being settled out, but does not involve any further removal of BOD. This focus is here to separating the treated. Here we are just separating things. Then we have ideal phase. This phase is transition phase with no active treatment occurring. So this is ideal phase. All the treated water, all the sludge has been removed. Not all the sludge, some sludge will be there in the system, and the system is ready for next batch. Settle during this phase, there will be settling also. So these options are not correct option. Okay now. So the correct answer is react phase. Which of these involve membrane waste biomass separation? Remember from the name. This is very easy question. I'm not going to discuss. Name itself suggests that this membrane bioreactor, that is only MBR. So the correct answer will be MBR. We have discussed too much. See, actually these slides are being uploaded on uploaded for none. You can see there only few people are attending the session, but I have to upload this video to a portal. So this PPT to portal. So that's why if someone is reading this PPT, he or she can have an idea So that's why whenever we are preparing the PPT, we try to include all the detail before answering any question. Okay, na. So this MBR, this process integrates biological treatment. Again, I have already discussed this thing. Okay, this MBR is moving biofuel. This SBR again, it's going again and again same thing. Which of these process occur in ideal phase? Again, just try to answer it. Just try to answer in that way, like what is the when this is happening, when this is happening, when this is happening. Then you will be able to answer it. Okay, now. Again, very simple question. But remember, these are simple question, but these kind of question are generally asked if you are appearing in any environmental examination. This if you means like if any question is coming in respect to SBR, this question will be coming by a one means or by another means, like in they will be just twisting the words, like okay now. So just remember the basics, remember those pictures, six phases there, water is coming, reaction is happening, then settling is happening, then descending is happening, then we have ideal condition, then finally our system is ready for next batch. Try to answer in which process. Just try to remember when is the removal of treated effluent happen, when the organic matter degradation happen, when sludge wasting is happening, when denitrification is happening. Then you will be able to answer when out of this process which phase is for ideal phase. We have got one answer, C. Huh. So the ideal phase is transfer where the no active aeration or mixing occur during this phase. So yes, C is the correct answer. Excess biomass can be removed during this ideal phase to control the concentration of solids in the reactor. Removal this occurs during descent phase. This occurs during react phase. Typically occur during a specific phase and means this also occur in during react phase only. Okay, na. So I hope this was very easy question, and I hope this is okay to you. Then we have advanced oxidation process target oxidation through OH radical, which is produced by this thing I have not discussed during this lecture, but if you have gone through your what do I call lectures uploaded on NPTL, then you will be able to answer it. Okay, na. This thing I have not discussed in last session. I think I have discussed little bit about this thing, but I think today I have not discussed about. So still there was question related to this thing, just to recall what we have discussed in during last session, and just to show that like you have to go through the lectures before coming to this online session. So this advanced process is utilize hydrox OH to efficiently oxidize wide range of organic pollutant in wastewater. In many AOP, that is advanced oxidation process, particularly those employing combination of ozone, H2O2, that is hydrogen peroxide, and UV light, are designed to maximize the production of this radical while minimizing energy consumption. Okay, na. So, miss like. So the answer for this is A, that is lower energy requirement and a smaller volume. So miss we are treating we are we are for oxidizing purpose, we are using these radicals in a very small volume, and the energy required for this is also very low. So this can be produced with the help of with the help of oxygen or sorry ozone or H2O. So there are some process by which this OH radicals can be produced. Once this radical can be produced, this can be used for uh, These can be used for oxidation purpose. Okay, na. So modern AOP are often optimized for energy efficiency, making them capable of operating effectively with lower energy inputs compared to the some traditional methods. A smaller reactor's volume ASP can be achieve high level of pollutant means in a small volume. Remember these are in the form of these are in form of water and all these things like some kind of chemicals. Okay, na. So what will happen that a small amount of volume is required to degrade our degrade our pollutant. Okay, na. And energy required for this is also considered to be low only, so that's why a lower energy and a smaller volume is best choice regarding the production of hydroxide in AOP. In comparison to external configuration of MBR, submerged MBR can operate at higher flux, have lower energy consumption, offer better maintenance control, all of the above. So what happened that there are two process of fixing this MBR. So what will happen that one MBR will be like always submerged in wastewater, and there will be one MBR that is externally some some other mechanism is there. Means it's not directly involved with the wastewater. So which of the this following is good? Okay, na. So uh, so I will be going through by one option. Can operate at higher flux. While submerged MBR can achieve effective flux rates, they might not be constantly operating. See, if someone is always in submerged in wastewater, so basically a huge amount of wastewater will be passing through it. So obviously can it will be having higher flux. Okay, na. Achieve effective flux, but they not be constantly operate at higher flux that external control. The actual flux performance can depend upon the various, including falling tendency and a specific design of the system. So this is miss. Now remember, a huge amount of loading is coming, so that is not good for our membrane. Okay, na. So miss like it's not a good option to always provide a huge amount of wastewater to our MBR. uh, so this statement is incorrect kind of. So but coming to have lower energy consumption, uh, lower this is correct statement. Submerged is often have lower energy requirement because they are typically operate under low transmissible pressure. Means the pressure required, remember, whenever we are talking about membrane, there is always pressure required because it's not like that water will be passing uh, without any energy or all these things. We have to apply some kind of pressure. So what will happen that water will be moving from one side to one side, and all the colloids, all the suspended solid, and will be getting retained on this wastewater, this membrane. So but in this case, what will happen that in case of submerged MBR, a little bit less amount of energy will be consumed because there will be some kind of external um, uh, mm, some kind of additional pressure will be due to the wastewater which is present there. Okay, na. This submerged design reduce the energy needed for pumping, making it more efficient in terms of energy consumption. Coming to the other option, offer better maintenance. No, it does not offer better maintenance. External maintenance control can vary between submerged and external. While the submerged can, because you know it's already submerged, so you have to like maintain it on regular basis. So it does not offer better maintenance control. Okay, given this option, while submerged MBR have advantage, the statement that exactly have lower energy consumption is the most consistent in the context. The best option is have lower energy. Pump suction will drive the outlet from MBR. Yes, so it's kind of applying pressure. We are applying pressure from miss. Either we can apply pressure from one end, or we can suck we can create a suction, and in that way there will be a pressure difference, and the water will be moving from one side to other side. So yes, you are saying correct. The pump suction side will drive the outlet from MBR. So this it happens in summers. Miss, see, if we look into summers, so there is, whenever we are talking about submerged MBR, so there will be some kind of miss. I'm not exactly gone through the submerged in details, but as far as I have read, so there will be some kind. How compare with this option? Which just first let me check this first, the pump suction. The pump suction side will drive the outlet from MBR. Okay, it happened in summer MBR. Okay, what do you want to
Actually,
say?
it will happen in submerged MBR because I operated a submerged MBR. Pump section to get
Ha.
TMP, transmembrane pressure, pump section side will be connected to the membranes.
Okay. You might be correct, miss. I have not. I have just gone through theory parts. So based on theory discussion, I am just trying to answer the question.
Okay,
Uh,
okay.
okay, but I'm not aware of these things. Okay, how compare with this option? Which option? Which option? How compare with this option? Uh, which option? Oh, this submerged MBR and external MBR. Okay. So generally, see, if we in see, right now I'm not gone through the mechanism and all these things. So what might happen that in external configuration of MBR, the amount of energy uh, which is needed might be higher, because we have to like uh, the amount of energy. Right now I can say this thing only, but for your interest you can always go check on some specific book related to MBR. Okay na. So if we talk about energy consumption, it is suggested that book has suggested that the submerged MBR have lower energy consumption as compared to the external configuration, because it's all see, if you miss, like one person has said that there is some kind of pump suction side will drive the outlet from MBR in a submerged MBR. So that in the in it might be it might be resulting in the less energy consumption. So that might be a case. So I'm not also aware of this thing, but I will try to get into this, and I will, if you attend my next section, I will try to answer it in more detailed way. For now, this be the correct answer. I hope Miss. See, I think I'm not able. I was not able to answer the question, but I'm just suggesting that you can refer any standard book or just search on internet how these configuration is happening, submerged or submerged MBR and external MBR. But based on my whatever I have studied in the past, I can only say that this submerged MBR require less energy as compared to the external configuration. I hope this is clear to you, but I will try to get back to you in the next session. If you attend, I will just try to answer it in a more detailed way. I have to look through into it. So I will be, we have only 10 minutes left, so I will be moving little bit fast. So we have another option that a MBBR, moving bio, see, reactor is conceptually a ASP supplied with inert media as a biofilm carrier operating in mix option. MBR operating under batch. So this is incorrect option. This is also incorrect option. Either A option will be correct or B option will be correct. Okay now. So hmm, the type of biological treatment system where biofilms grow on a moving part that's kept in suspension within this allow the efficient mass transfer and biological treatment. This thing we know. So so this is correct. So answer A is the correct answer, that this MBR can be seen as activated sludge process that incorporate insert media. So it's like it's like here we are on a moving bed. Some kind of media is there, some kind of inert media is there that is allowing to grow biofilms and all. Okay now. So obviously this option is related to membranes and this option is also related to membrane, so this cannot be answered. And in SBR, they are not a specifically combination of sequential. MBR operates continuously, unlike, so we know that there is a continuous flow in MBBR. Okay now, so it can be the A is the best option out of these things. Okay now, coming to the 13th question. This image represents, this is a inert media. Okay, so membrane support media using submerged MBR, inert media for biomass growth and biofilm, open surface uniform mixer, and mini aeration device. So I think uh, B the correct answer. Yes, this image represents inert media for biomass growth and biofilms carrier. These images shown in are plastic media often used in biological treatment such as moving MBBRs or submerged membrane bioreactors. These inert media provide a surface for microorganisms to grow and uh, form biofilms, uh, which enhance the treat which enhance the treatment by increasing the biomass without occupying significant space within the reactor. Mhm. So all these option, so this is the correct option. They are not by membranes, obviously, not mixture. This is I don't know. So among the following waste removal suspended solid, again this is very simple question. We are talking about suspended solid removal and biomass. Only one option is correct. So this MB membrane we have discussed also. This membrane is allowing both thing to control the solids also, because there will some kind of a specific size will be there of that membrane, and water will be flowing through that specific site, specific pores. So the correct answer is B. Okay. So I have just discussed all these option also, but out of this, the B option is correct option. See, all option are able to remove suspended solid, or but it's all about efficiency. Which one is the best option? You have to always try. See, every treatment method is able to remove some suspended solid and biological organic matter, but the question is who is most effective. Okay, so here when you will suppose if you have got, if you miss, if you will get this PPT, so just try to read out and you will get idea that I have written that every method is able to remove some kind of some there is some efficiency, but this MBR has highest efficiency. Coming to the last question, match the following. This SBR, MBR, MBBR. Okay. This question, I think this is a combination of all the past question which we have discussed. SBR is here. See, combined with ASP and membrane filtration. We are not using in SBR. There is no filtration. Okay, now ASP process operated in batch. So this will be matching with one. This MBR is the MBBR is there. We have got one answer. Oh, so A. Sorry. Then we have this MBR. Again, we know that in MBR we are using some kind of membrane. Only one option is with membrane, and then this we are M. Sorry, I said something wrong. Uh, Third option is this. Sorry. I was correct. This is 2, 1, and finally this is matching with 3. So yes, A is the correct answer. So this SBR, we know that sludge activated process in different system. Again, see, I'm using same thing again and again. MBR is combination of ASP and membrane filtration. Then we have this MBBR, ASP augmented with biofilms carriers. So the correct answer is A, B, A, C. Okay. So that was for today. I hope I have tried my best to explain everything which I know. So two more sessions are remaining. That is on next Tuesday, and after that next Tuesday. So if you have any kind of doubt, you can ask, or we can end the session here. And I request you to join next session also. Again, I will try to explain as much as I can, and I will also go to this session, this question. I will try to get the answer of this question. Okay, so when we get that, you have to ask from NPTL team. That I don't know, but I think 1 week before your exam, in the month of April, there was exam, and the whole ticket was distributed 1 week before the exam. So just wait, they will just announce everything very soon. Any more question? Not, then we, I think that's all for today. I'm ending the session, and stop sharing. Stop sharing. Where does it go? So that's all for today. We have I Any question? Anyone? Subhas? No, sir. Okay. Then that's all for today. Thank you for attending my session. See you next week.